All right, we're going to look today at lesson 4.1. And lesson 4.1 talks a lot about, it's called half as much again. It talks a lot about these things called tape diagrams. In your book, I believe we're starting on page 31. It asks, what do you notice? What do you wonder about these things? Some of you may have used tape diagrams before. Some of you may have not. They're a way to visualize fractions and decimals and kind of what's happening with a problem. They may help you. They may not, but this is kind of the first time this year that we're seeing these, so we're going to work through these. So first question just is, what do you notice? What do you wonder? You can skip that one. All right, our lesson starts with this activity 4.2, walking half as much again. So we've got Jada, and she has all these relationships, and the people and animals and things that she knows are walking. And then they're walking half that length again. So the question is, how far is each of these people or things going? Jada's pet turtle walked 10 feet, then half that length again. So the question is, this is the turtle in the first one. How far would that turtle have walked altogether? Well, originally the turtle walked 10 feet. Then it walked half that much again. Well, half that much would be 5. So in total, the turtle walked 10 plus 5, or 15 feet. And you're going to do that for each of those. If her baby brother walked 3 yards, then half that length again, what would that be? How much would that be? Well, we're getting into some decimals here, or fractions, right? Half of 3 is 1.5, and 1.5 plus 3 would be 4.5, or you could write 4.5. I want you to think about that for 4.5. What's half of 4.5? And then add it on to that 4.5. Same thing with 1. What's half of 1 added on to 4.5? The last one asks you about a person walks X meters and then half that length again. How could you represent that? So pause for a minute and fill out that table. And then when you're finished, question 2 asks you to explain how you computed the total distance in each case. So give me an explanation. What did you do in your head to calculate each of those distances? Question 3 is asking about 2 students each wrote an equation to represent the relationship between the initial distance walked, x, and the total distance walked, y. So that would be our last line here. And 2 students wrote that relationship. Mai wrote y equals x plus 1/2 x, and Kieran wrote y equals 3 over 2x. And the question is, as we turn the page, at the top of the page, do you agree with either of them? Now remember, with this curriculum, you might end up agreeing with one of them, or the other one, or both, or neither. So explain your reasoning there. Okay, so pause and answer that question. And now we're going to skip the Are You Ready for More? And we're going to look at these this exercise 4.3. These involve tape diagrams, and before we go over the questions that are in 4.3, I want to explain to you how tape diagrams work. So with a tape diagram, what you're going to be given is, this curriculum seems to like these blue boxes. You're going to be given a blue box. They're going to label it X. That X represents 1. That's our whole. So that X, we always want to think of as that's kind of our base value, our 1. Now that X, what's going to happen is it's going to be divided into a different number of sections based on the problem. And what you need to do, what you need to pay attention to, is how many sections it's divided into. So that 1, that whole, could be divided into 2 equal sections, in which case we would think of the 1 as 2 over 2. So I want you to write down the number of boxes, write down that whole part to whole ratio. That whole could be divided into 3 equal sections. The whole is still 1, the X is still 1, but we would be looking at 3 over 3 there, 3/3 to fill out the whole. It could be divided into 4 equal sections, 4/4. So that number of sections that it's divided into is important to us because it determines where we're going with the problem. So what I want you to do next to each one of those tape diagrams is write that whole number next to it. And the reason I want you to write down that 4 out of 4 is because then they're going to add to it. So we have this blue thing, this x, and we notice with this little squiggly bracket up above, that's showing us where the 1 ends. Now that 1, though, has been extended. They've added extra onto it. They've added this piece. And they're telling us when we do that, now we have this new thing. This thing we'll call y. And what they want us to do is think about how that y is related to the x. Well, notice that that amount that they added on is the exact same size as these partitions were to begin with. So it's adding 1 extra fourth. So this y is 1/4, 2/4, 3/4, 4/4, 5/4. We've added an extra 1/4, 2/4, 3/4, 4/4, 5/4. So we would say y is equal to 5/4 of the x. Or we could say y is equal to the regular x, the x that we started with, plus 1/4 of what that x is. In words, we might say y is 1/4 more than x. So those tape diagrams, they're showing you how many partitions, and then they're going to change it for the y value. And what you want to recognize, again, is that those amounts line up. The x is divided into an equal number of sections, partitioned equally, and now we're going to add or subtract from there. You might see the y looking like this. And again, we want to write a relationship between those two things. The x, again, is still divided into those 4 equal sections. And now we notice we've got one of those equal sections missing. So instead of being 1/4, 2/4, 3/4, 4/4, now we have 1/4, 2/4, 3/4. So our y is equal to 3/4 of the x. We could also say y is equal to the x decreased by 1/4 of itself. 1/4 of the x. We've taken 1/4 away. Okay, so we're going to watch for that. We need to count how many boxes that x is divided into. And then think about, are we increasing it or are we decreasing it? I'll just do one more quick example here. I've taken that x, it's the same length as the other one, but I've divided it up now into 1, 2, 3, 4, 5, 6 equal boxes. So my whole, my 1, is 6/6. So again, that x divided into 6/6. Now I'm going to extend it. So we've made a longer thing. We've got the x plus a certain amount more. I don't know how much more. Let's see. That would be 1 extra section, 2 extra sections, 3 extra sections, 4 extra sections. So I'm noticing 1, 2, 3, 4. So again, that y is divided up into equal segments like the x is, but instead of 6/6, let's count how many sixths we have. 1, 2, 3, 4, 5, 6/6. There's our whole 7, 8, 9, 10 sixths. So our y would be equal to 10/6 of the x. Or, again, we could say the whole x, 1 whole x, plus 4 extra sixths of the x. Now we could simplify that down. 1x plus 4/6 and 2/3 are the same thing. Or y equals 10/6x is the same as 5/3 x. Okay, so look for, again, that partition. How much is that x being divided into? And then is it getting longer or is it getting shorter? Are we adding to it or taking away from it? All right, let's try exercise 4.3. Okay, so for each of these x's, they're divided the same way. Each one of them is divided into 3 sections. So that blue part is 3/3. So the whole is made up of 3. 3/3, 3/3, just the blue part, remember, not what's added on here, 3/3. Okay, so as I look down at the y now, in exercise A, I have 1/3, 2/3, 3/3, 4/3. So I've added an extra third. As I look in at letter B here, I've got again those same amounts. Those are all thirds: 1/3, 2/3, 3/3, 4/3, 5/3. So I have an extra 2/3 of the x. As I look at C, now in C I've taken away. I have 1/3, 2/3. The y would equal 2/3 of the x. And in D, I only have that 1/3 of the x. Okay, so these are a little weird to get used to. They can be helpful to help us solve some problems. They can also be a little strange. So this exercise actually turns on to the next page. We're supposed to match these situations with one of these diagrams. And it says a diagram may not have a match. So I've added these in here. All right, it says Han ate X ounces of blueberries and Mai ate 1/3 less than that. So the key phrase there is 1/3 less than that. Not 1/3 of it, but 1/3 less than that. So as I look at those diagrams, which one am I going to choose? Well, which one is 1/3 less than the original one? Well, I think it's diagram C, right? That was 3/3. Here's 2/3. So 1/3 less than that. So letter little a would match with capital C. Mai biked X miles and Han biked 2/3 more than that. Well, let's see, 2/3 more than the original. Here's the original. Here's adding 2/3 more to that. B goes with B conveniently. And the last one, Han bought X pounds of apples. Mai bought 2/3 of that. I think that's also letter C, right? Notice how these are worded. In letter A, Mai ate 1/3 less. Han bought 2/3 of that. Those are actually the same thing, right? 1/3 less than a whole is 2/3. So both of those are answered by C. So again, a little weird getting used to these tape diagrams, but I have faith in you. Right? I want you to try we've actually kind of done this where I wrote down the x's and the y's. Can you write the equations for these diagrams? So for diagram A, that's the one up on the top here, top left, we will write our y is equal to, and again, we've already done this, it's this, 4/3 of what the x is, okay? So just throw that y equals in there, and we are good to go. It says, write a story for one of the diagrams that doesn't have a match. So use Mai or Han or Priya or your own self. Somebody did something and added to it or subtracted from it, right? Just a quick little 1 or 2 sentence story. And then for activity 4.4, we're going to do that tomorrow during Zoom. And that's about it, guys. I'm going to throw you some practice problems in the book. Have a good day, and we'll see you soon. Bye-bye.